Okay, so I'm a little bit sick today, but I'm still gonna record a video because the rule I set for myself is I can't not do a video 2 days in a row, even if I don't lock in 2 days in a row. Because video doesn't take that much time, even if I really don't have time to lock in, which is untrue for both today and yesterday because I could have just not procrastinated, but then again I couldn't have because I'm me. Anyways, if I remember correctly, these four has been videoed, so we're starting from this one, which is still that same contest and problem 14, 15, 17, 18. And as you can guess, that would imply that I got 16 correct because I'm him. Okay, yeah, 14 I also got right, but the thing with this one is I really wanted to remind myself of a smart trick I used. This was actually accidental discovery. I was trying to draw a regular octagon. The strategy I used was I drew a circle first, and then I connected 8 of equal distant points and made an octagon. And with that circle, I realized that it was a square. The quadrilateral, associate quadrilateral, is clearly a square because of the properties of a circle. And if I hadn't drawn that circle, I surely would not have realized that. And then it was also because of the property of a circle. I realized that. Okay, let's see if they have a graph here. Okay, yeah, I realized that from the center, this point, from the center point to the side of the square, and from the center point to this here, if you know, these two segments are also the same because obviously they're both the radius. So with that, I found that this area, I found this area's ratio to this whole area, the triangle's area's ratio to the quadrilateral, and obviously that's going to be the ratio of the whole square to the whole octagon as well. So yeah, drawing a circle outside of any regular polygon, I think, is very useful. Even though it was actually an accidental discovery by me, and holy crap, my voice is terrible right now. Okay, I'm not sure if it's a flu. Google said it's probably COVID, and I don't know which one's better. And also, I had to play tennis tournament today. 15. Ooh, this is an interesting one. So, complex number solutions. I remember the first time I learned about this was 2 summers ago, and I completely forgot how to do it when I came across this problem in the mock back on August 22nd. I did remember that there was a way to solve an equation that's z squared equals -1, which is very similar to not z squared. Z cubed is equal to -1, which is very similar to this equation, which is essentially z cubed is equal to 8, right? Because technically there's only one solution to both those. Like to z cubed equals -1, the one solution was just -1. To z cubed equals 8, the one solution is obviously just 2. However, the actual method on how to solve for the other two roots, just as I learned 2 summers ago and I had to relearn a few days ago, was that you factor out the root that is clearly a root here is z minus 2 because positive 2 is a root. So z minus 2 has got to be a root. So you basically do long division, or I guess synthetic division. So z squared, so that's 10008, right? If I'm not mistaken, due to the first, second, third, 1008. Sorry, 1008. Do synthetic division with the root 2. You get, if I remember how to do this, I don't remember how to do this at all. Anyways, it might be long division too, but I'll learn synthetic division. I'll relearn synthetic division very soon. Anyways, you basically get this thing. Yeah, this thing. And then this is clearly very quadratic formulable, and then you quadratic formula on it, and the other one is clearly very easy to solve as well. I think you factor by grouping or something. Yep, factor by grouping. So yeah, this is just a whole factoring technique problem, and then finding the farthest point on the complex plane, that's just easy. 17. Oh yeah, this was an interesting one. I was in the middle of solving it as my contest ended, but essentially, um, let me think. Yeah, I essentially listed out the equation, but my mistake was I didn't actually combine enough of the like terms, because after combining like terms, you get an equation that's basically ln of n x plus 1 x plus 2 divided by ln of x plus 3 is equal to ln 91 over 90. I know you can't see what I'm writing and you can hear that I'm writing something, but anyways, you get this whole thing, and then x plus 1 x plus 2 has to be equals 91, which factors out to be, if I remember correctly, 13 times 7. And give me 1 second. Excuse me. 13 times 7 is clearly not a valid x times x plus 1 x plus 2 because those has to be exactly 1 apart. But then you realize that 13 and 14 actually works. So 13 and 7 times 2 works. So if we're adding 2 to the numerator, we also have to add 2 to the denominator. So when we factor out 90, we get 9 and 10. But since we get another 2 now, so now we have 3, 3, 2, 2, 5 at the bottom. And we had to piece them to be two numbers that are exactly 3 apart. So let's try it on the spot because I actually don't remember what the exact result is either. So the 5 is clearly big. I would probably want to pair the 5 with the 15, right? And then the other is 4 and 3, which goes to 12, and that works perfectly. So we have 12 and 15 on the bottom, 13 and 14 on the top, which clearly works. So that leftmost is just 12. If I'm not mistaken, yup, I'm him. And then 18, right? Okay, we need a graph. Here is our graph. Okay, this is another very, very good problem. I tried to do some goofy stuff and I just figured I didn't have enough information, but this is actually not true because let's go back to my notes. There was two very important things I needed to know. Altitude geometry theorem or power of a point, which actually power of a point I learned during ARML last year, and that's another thing I need to review. So yeah, I guess I'm gonna review this problem after I learn those. So yeah, thanks for watching, and I'll see you tomorrow or the day after tomorrow. Hopefully tomorrow, because the limit is no 2 days without videos.